Okay, let me simplify it. Okay, this is a figure. Okay, I have taken this figure from Wikipedia. So here I have an instance. Okay, and then what I have done is I have created n trees. N can be anything. By default in scikit-learn, it's n equal to 100. Okay, this is the default value. We can always change it. Okay. And we will also look into some ways which by changing the n values we can get far better results. Okay, so by default n value is 100 in scikit-learn. So we have, let's say, 100 trees over here, and from those 100 trees, okay, what we are doing from those 100 trees, we are predicting the results. Okay, so from tree 1, so let's say from t1 we are getting class A, from t2 we are getting class B, similarly till t100, that is the tree 100 tree, we are getting, let's say, for 300 also we are getting B. After doing everything, we found it out that out of 100 trees, there are, for A there is 30 values, and for B there is 70 values in total, which gives me 100, right? So we can say the new instance that we have got it out, okay, the majority voting rule, from new instance that we have got it out, it will belong to the class B. Okay, as majority of the my decision tree has told me that it belongs to the class B. So that's how our decision tree algorithm works. Now let's look into the advantages of decision tree. Decision tree is capable of performing both a regression and classification tasks. This is one of the major advantages of the random forest. Okay. One of the major advantage of random forest is that we can do regression and classification tasks. It is also capable of handling large data set with high dimensionality. I mean that when we have various features, it this algorithm, random forest algorithm, can easily handle that. Okay, so here we have handle large data set. It produces good prediction, okay, which can be easily understood. It most of the time it predicts and does a better job than decision tree. Okay. It enhances the accuracy of the model and prevents the overfitting issue. This is the major reason why random forest we always try to do much more in random forest, because it prevents the issue of overfitting, which we looked into over decision tree. While we were learning about decision tree, we looked at one of the major demerits of decision tree was that it was having the problem of overfitting, but random forest just prevents that problem. Okay, these are the major advantages of random forest. Now you know that one coin has a head and a tail, so we have two faces in a coin. So if there are advantages, there will be always some disadvantages. So let's look into the disadvantage. The complexity of the algorithm is much higher when we have more than 100 trees. By default, there are 100 trees. To do so, the algorithm requires high computation power and resources. So it takes a lot of time. Okay, it takes a lot of time to execute a random forest algorithm. Okay, it has a longer training period. It has also the complexity of the program also increases. Let's say you are creating a decision tree where you are creating a random forest where n trees is equal to 1000. So 1000 trees will be created for the data set. It will take a lot of time. It will take longer time to train the data, and at the end, computing power and the resources will be much more higher. So the complexity will obviously increase in this. One more disadvantage is there, which I haven't written, that even though random forest is used for classification and regression problem, it is not really much suitable for the regression task. So I really highly prefer it to use just for classification task. Most of the time random forest doesn't really do a great job in regression task. So that's it for the theoretical aspect of the videos. Okay, theoretical aspect of random forest. In our next part of this section of random forest, we are going to start out with the lab. Okay, in the lab part, we are going to implement our first ever random forest classifier model. So let's catch up in our next part.